In this question, you have a 180-degree elbow forces the flow to make a U-turn and discharge it into the atmosphere. Discharge it in the atmosphere, it means at station 2, this one is atmosphere. Atmosphere station 2, it means we have P2 equal to atmospheric pressure or 0 gauge pressure. Okay, atmosphere. At a rate of 40 kilogram per second. The rate of 40 kilogram per second. It means we have the mass flow rate equal to 40 kilogram per second. The diameter of the elbow is 10 centimeter. This one, the diameter of the elbow is D, here is 10 centimeter or equal to 0.1 meter. Convert to SI unit, 0.1 meter. The width of the elbow and water in it is considered to be, you can ignore the width, okay? You find, question A, gauge pressure at the center of the inlet of the elbow. This means you find P1. Gauge pressure. Gauge pressure P1. And B is the actuating force needs to hold the elbow in the place. Take the momentum flux correction factor to be 1.03. Okay, so now we will focus on question A first. 5P1. How to 5P1? How to 5P1? P1 here, pressure P1. How to find pressure? We have 3 main equations. This one, 3 equations here. So which one we will use to find pressure P1? Bernoulli, yeah. Bernoulli or energy. Bernoulli is energy equation for ideal flow. Okay, because you have to see for the mass conservation, no pressure. So maybe you don't apply this one to find pressure. For the momentum equation, you have pressure because you have pressure force. But in this case, in the question B, we have to find the force. So maybe we will apply the momentum equation in the question B. It means we will apply the energy equation to find pressure P1. Okay. So energy equation to find P1. We have this one is station 1. This one is station 2. Okay. And this one is V2. This one is V1. And this one's in here you have P2. You have P1. With P2 is 0. Okay. So for question A, you know that we will apply the energy equation or Bernoulli equation between point 1 and point 2. Okay. Equation P1 over rho Z, V1 square over 2Z. That's one. Between 1 and 2, no pump, no fan. So S added 0. Equal to in the right hand side, P2 over rho Z, V2 square over 2Z. That's 2. No turbine between 1 and 2. So ignore it. And because this one is because in the question it's not mentioned to the energy loss, you can assume this one is ideal flow. Okay, for ideal flow, energy loss is 0. So this one is equation, Bernoulli equation or energy equation between point 1 and point 2. And here, P1, we have to find this one. And what we have in this equation, P2, we have this one is 0. Atmospheric pressure. How about V1 and V2? V1 and V2. How about V1 and V2? How to find V1 and V2? V1, V2, yeah. How to find V1 and V2? The mass flow rate, yes. Using the mass flow rate, you have, it means you have V1 equal to mass flow rate divided by the density times area A1. V2 equal to mass flow rate divided by density times area A2. Mass flow rate equal to density times velocity times cross-section area. It means you have V1 equal to V2. Same diameter, same velocity. It means you can cancel out kinetic energy here. You don't have to find V. You can cancel the kinetic energy in the equation. This means you will have P1 equal to rho Z Z2 minus Z1. This one equation. And how about Z1 and Z2 minus Z1? Density, this one you have is 1000. Gravity is 9.81. How about Z2 minus Z1? Yeah. This radius is 50. Okay, so this distance, Z2 minus Z1 will be equal to 2 times 50 or 100 centimeter or 1 meter. This one is 1 meter. So P1, 1000 times 9.81 times 1 or 9 S10 Pascal. Gây pressure. Okay, gây pressure. So pressure you can find from energy equation. Energy equation. Got it? Energy equation we studied last week. Okay. You have any question?
No.
Okay. So question A, that's easy. Question B, you find the force needs to hold the elbow in the place. Okay, question 2. Question B, I try it again. Okay, I use this one first. You have, I use this one is X. This one is Y. Okay. It means we will have to hold this elbow in this place. We have to apply a force to this elbow. I assume this force is Fx here, Fy here. Okay. I assume Fx and Fy like this. When we have Fx and Fy like this, this one is force applied to the elbow to keep this one is this place. Okay, it means if you want to find f, you have to find f and fy. So to find x and fy, similar to question 1, you have to apply the momentum equation in x and y direction. Okay, so firstly, fx or in x direction. I give you 5 minutes to find fx in this case. Okay, 5 minutes. You have fx, yeah. This one is 1. This one is distance 2. And we have v1, v2, and at here we have p1, p2, x direction. Okay, you have 5 minutes to find x. Fx. Yeah, the equation we have is sigma fx equal to sigma out beta m v out x minus sigma in beta m v in x. Okay, the equation. This one is x direction. Fx. Okay. Minus 484. Minus 484. Okay, let's see. I have here is minus 497. So let's see. Let's see. Now we work together. X. Okay. Because here we have station 1 and station 2. We have P1 and P2. So we will have the force F2 and the force F1 from outside to the control volume. But F2 equal to P2 times A2 will be 0 because the pressure P2 is 0 pressure. Okay, so the equation in the left hand side we will have Fx plus F1. Okay, with F1 here, with F1 equal to pressure P1 times area A1 is pressure force equal to is the right hand side beta. Oh, maybe because you use beta is 1. Okay, so the results have the different here. The beta in this question is 1.03. Maybe you use beta is 1. Oh yeah. So if in the question it mentions to momentum flux correction factor, you have to use this one. Okay, so this one is 1.03. 1.03 times mass flow rate. V out x is V2x. But V2 in from right to left, so this one is minus V2. Because V2 from right to left, x from left to right. Okay, minus 1.03 mass flow rate. V in x of V1 from left to right, so this one V1. Okay, with V1 here, mass flow rate divided by density times cross-section area A1 equal to mass flow rate divided by the density times cross-section area. Or this one equal to mass flow rate you have here is 40 kilogram per second. It's 40 divided by density is 1000 times area. The diameter you have here is 0.1 meter. So pi times 0.1 square over 4. Okay. So this one, velocity V1 you have here is 5.1 meters per second. Similar for V2, V1 equal to V2, 5.1 meters per second. 5.1 meters per second. Okay, velocity equal to mass flow rate divided by density times cross-section area. Mass flow rate here you have is 40 kilogram per second. This one is 40 kilogram per second. F1 here you have is P1 times A1, or equal to P1 is 9S10 from question A times pi 0.1 square over 4. Okay. So everything you have. So everything here you have. You have F1 you have. Mass flow rate V2 you have. V1 you have. So you will have Fx is negative 497 Newton. You have Fx is negative 497. It means you have Fx is 497 Newton and Fx from right to left. This one is Fx right to left. Okay, not left to right as assumption as being Fx actually from right to left, not left to right. Okay, so you have Fx. Now you have any question? Any question?
No, it's all good.
Okay, so now you have 3 minutes to find Fy. Fy. In y direction. You have sigma Fy equal to sigma out beta m v out y minus sigma in beta m v in y. For Fy. Yeah. Yes. Fy. Same thing. What do you mean?
Actually, never mind. I think. Let me try again.
Okay, try it. Yeah, you're right, it's 0. Fy is 0. Here you see, it's going to equal to Fy plus F1y, okay, equal to beta m Vry is V2y, okay, minus beta muscle rate V1y, V in y or V1y. And in here you have F1y 0. F1 only is in x direction. V2y 0 in x direction. V1 V2y, this one is 0. So it means Fy is 0. Yes. Fy is 0. So it means the force in x direction. Okay. It means now here in this one, this force not this one. So the force here, F force will be in x direction from right to left, and the magnitude will be equal to 497 Newton. Okay. F equal to Fx in x direction only. Okay. Do you have any question? Any question? Any question? Okay, thank you.